talk about secondary growth in stems. There's two meristems that are responsible. Now, this is very similar to what we talked about secondary growth in roots. So I'm going to kind of be a little bit more cursory with the explanation than I was before. But if you don't understand, make sure you talk to me on Zoom, and maybe we can try to clear up anything that doesn't help. I mean, that doesn't make sense to you. So there's two meristems. There's the vascular cambium, just like in the root, that is going to give rise to secondary xylem and phloem. Xylem towards the inside and phloem towards the outside. And then the cambium, just like in the roots. But in this case, instead of being derived from the pericycle, it's going to be derived from the cortex. The parenchyma cells in the cortex are going to become meristematic because they're constantly replacing the tissue that has been broken up by the expansion of the rings of xylem. And that is going to be replacing the epiderm and the cortex that was there initially with the periderm. And it's going to be the cambium, of course, or the periderm, of course, includes the cambium, the phyloderm towards the inside, which is basically a layer of parenchyma cells next to the phloem, and then the cork that is on the outside of that. And every year there's new cork. So the cambium of this year is the most active, is the active one. But you can see layers of cambium and cork from previous years towards the outside. So I think we kind of mentioned that before, but anyway, let's just kind of look at this. So this is like the arrangement that you would normally see in a stem, and of course we're talking eudicots here, not monocots. Monocots growth is somewhat different. We'll talk about that maybe a little bit more. And as the plant matures and starts to grow the second year, it's going to add the xylem towards the inside of the vascular cambium. This is going to, at first, just push these other xylem pieces, that is the initial xylem pieces, towards the center, crushing the pith. And after that pith is crushed, then it's going to expand the plant outward. And when it does that, it's going to be breaking up the phloem. So these are trying to show you the original phloem. I did it with different colors on the root. And then the phloem that is this year's secondary phloem. And after a while, because the phloem keeps getting broken up, I mean, that is the space for the phloem keeps getting broken up, the expansion will eventually just make one little layer of phloem, because it all sort of coalesces, and many layers of the xylem. Well, this isn't showing that, it's just showing you the start of the periderm. That is, the cortex is going to start dividing, having a layer of the, replacing this cortical layer with the periderm. So at first you'll still see the cortex there, but the periderm will start to form, and then after a while it'll just like completely replace that. If you look at this one, let's see if it's upside down here. All right. If you look at this one, this is showing you like what it would look like after a bit. So each one of these lines is a ring. So this tree would be, I don't know how old because I haven't counted these, but 30 years old or 50, I don't know. Anyway, if you look at this, you can see that the xylem, of course, crushed that pith in the middle. You have the primary xylem, and then all these are secondary xylem rings. And within that is parenchyma that exists as rays that are going outward. These parenchyma cells are going to help replace any kind of cracks in the wood and so forth that might occur as the plant grows. And then right on this surface would be the vascular cambium. On the outside of that would be the phloem. And remember, it's getting broken up as the tree expands. And as it gets broken up, each year it's just going to fill in with more phloem. And so, in essence, it's going to make one ring that is continuous around the plant that is much thinner than the xylem. It doesn't add on in layers like the xylem does. And then outside of that would have been the cortex. What originally would have been in the cortex is being replaced by the periderm, where you have the phelloderm and this year's Coronacam, the closest to the phloem surface. And then outside of that are other years of cork and Coronacam. All right, so again, I wanted to just show you, this is just a depiction of how the vascular cambium is going to lay down new xylem and phloem. And this is a depiction that is somewhat useful to look at because it shows you the wood. So it shows you like let me see if I can get better focus here. Shows you the wood vessels and so forth that would be going up and down, the pits and so forth. But it also shows you things like resin ducts. So in the xylem, especially the secondary xylem, and not this year's secondary xylem, which would be the functional xylem, but the old xylem is going to have resin ducts throughout it. And those resin ducts are going to have resin that helps reduce herbivory of the plant and also disease and insects and so forth. These are showing you the rays of parenchyma that can exist in a radial way. That is, they are coming from the center of the plant all the way out through the xylem, this is all the secondary xylem, and sometimes even into the phloem. And those, of course, are replacing or helping replace any cells that might get damaged or lost during that time. Now, some other things that we want to talk about here are just some terminology. As you lay down the periderm, there's what was the stomatals function, which was gas exchange. There has to be left in the periderm some holes, and these are called lenticels, and they exist in the bark. Some bark is just very holy, so to speak, and other bark really needs like a lenticel or an opening that allows for gas exchange for the cellular respiration and photosynthesis activity. Now, there's not a lot of photosynthesis or any photosynthesis in the periderm, so it's mostly for cellular respiration. And I wanted to talk about the difference between softwood and hardwood. Softwood is wood that grows very fast. So a pine tree, for example, grows very fast, and because of that, the xylem vessels are very big, and if you were to cut it, it would be reasonably soft, versus a hardwood where the xylem vessels are very, very small and very close together, and is very slow growing tree. And over time, the layers of xylem are not adding as much body, but the body is harder. And things like oaks and so forth are what we would consider hardwoods. I put this here just so you know the difference in the cuts. This is all about like if you were cutting wood from a log. A transverse section would be like a cross section, radial would be right through the middle, and tangential is kind of sideways through the wood. One other thing, or two other things, there are sapwood versus hardwood. Sapwood is wood that is functioning and it has water in it. What mainly is talking about the xylem and that functional xylem. So it's the last secondary xylem that is added this year, and heartwood is in the middle and it has a lot of resins in it. Reaction wood versus compression wood. What we're talking about there is reaction wood is when a tree is leaning. The compression wood is on the side that it's leaning towards, and the tension wood is on the side that is trying to hold the tree up.